Welcome to session 175 of Scanner School. We teach you everything to know about the scanner radio hobby. All the notes from today's podcast can be found on our website at scannerschool.com/session 175. Today's podcast is sponsored by our two brand new training courses. Our free SDR course, The Ultimate Beginner's Guide to Software-Defined Radio, will get you started with SDRs in an afternoon. We will show you what hardware and accessories to buy to get started with software-defined radio. Then we'll show you the step-by-step how-to install the drivers, tune your first frequency with SDR Sharp, and then have you monitoring digital at the end of this free course. Our advanced course continues with the beginner's course left off and levels up your SDR experience. In this course, you'll learn even more about software-defined radio. We will show you how you can substitute an SDR for your high-end digital scanner, how to monitor HD radio, monitor trunk systems and overhead data with Unitrunker, and even how to monitor all the talk groups on a system and never miss a beat with SDR Trunk. You can sign up for both courses at courses.scannerschool.com. Before we start this week's podcast, I'd like to take a moment to thank our Patreon supporters. Patreon is a month-to-month sponsorship platform. We have 3 different support tiers, each with different benefits. But the most valuable tier is our $5 a month tier. This equates to sponsoring the podcast for about $1 per episode. Now, not only do our $5 Patreon supporters receive the podcast early, but they also receive a commercial-free version of the podcast delivered directly to their podcast player. Some may say that the included squelchy sticker pack that is mailed to your home is the best benefit of the $5 level, but I think it's the community or the club that is growing at this level. You see, we meet once a month on Zoom and we have a roundtable discussion about scanning, ask questions, offer advice. Some of the members are answering other people's questions, and we just talk with our fellow Scanner School classmates. This is an exclusive group for our $5 Patreon members. Now, again, if all this wasn't enough at that level, you'll also receive discounts to upcoming Scanner School courses and offerings. Now, you can help support Scanner School by going to www.scannerschool.com/Patreon or www.scannerschool.com/support. Now, I'd like to thank all of our Patreon supporters at all levels, and they are Blurpy Benner, Brian King, Buzz Gold, Chris Paris, Craig Harper, Dan, Dave Pasco, David C., Danny Crotty, Ed Walsh, Eddie K., Edward Bramblett, Evan Barak, Gary Fletcher, Guy Lee, James Brogson, James Felling, James Peruta, Jeff Block, Jenny Taylor, Jim B., Jim Heinrich, John Goldenberg, Ken Newberry, Kevin Zwicky, Lenny Bauer, Les Stevenson, Mark Beebe, Mason Kramer, Michael Kroger, Paul Teal, Raymond Hill, Robert Kanzler, Ronnie Bach, Sal Marandola, Signals Everywhere, Tim Mazza, Todd Glendy, and William R. Kant. Now let's start the podcast.
Welcome to The Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
Welcome back to Scanner School. My name is Phil Lichtenberger, and my amateur radio call sign is W2LIE. This podcast is here to teach you everything to know about the scanner radio hobby. And we are looking to help you with your scanner radio questions and to help you get over that little hump that is keeping you from really enjoying the hobby. Now, on the first Tuesday of every month, we host an Ask Scanner School session, both in podcast format and also live. And we're on YouTube and Facebook and even Twitter via Periscope. And if it works out well, we also do it live on Instagram. But in order to do the podcast episodes, I need your questions. So if you can go to scannerschool.com/ask and ask me a question, I'll answer it on an upcoming podcast episode. But if you leave me a voicemail, you can also go to scannerschool.com/ask or also at 516-308-2885. I will put you in a running for that month for a free tutoring session. Now, a tutoring session is a one-on-one, like a help session, right? I can see what you see. We could talk over Zoom or over Skype, and it's a great way for me to at least thank you for coming forward and putting your voice on the podcast. Now, if you just want help and you want to go through a tutoring session, go to scannerschool.com/tutoring. So today we are talking about decimal, binary, octal, and hexadecimal. And yes, this has to do with scanning, and we'll put everything in a nice, pretty bow at the end of this podcast. Stick with me on this one. It's going to be a fast, very fast episode. So decimal, let's start here on something that we can all understand, is decimal systems can be thought of as human-readable digits. Basically, 1 through 10, 100, 1,000, 1 million, etc., right? These are easy for us to read, easy for us to see in our heads, easy for us to compute. And if we aren't using freedom units, they're very easy to convert from one form to another. For example, millimeter, centimeter, meter, kilometer. Again, right? Can you convert? I mean, I could do inches to feet to yard to miles sometimes. I mean, I can easily do inches, feet, and yards, but when you start throwing miles in the equation, it's like how many inches, how many feet, how many yards are in a mile? I mean, you got to look that one up, right? I mean, come on. Base 10 is just so much easier than, what we've got going on here. Come on. But thankfully, right, Heinrich Hertz was not American, and we measure frequencies in a base 10 environment, right? Hertz, kilohertz, megahertz, gigahertz, right? 1, 1,000, 1 million, right? Hertz. It's so much easier to move that decimal place around. But while that works well for humans, base 10 doesn't work well for machine languages or computing. So we have one of the very earliest forms of computer languages, and that's the binary system. Binary is just 2 bits, right? Zeros and ones. And I said bits here. I didn't say bytes, and we'll talk about bytes in a couple minutes here. So while a binary system is not the most efficient form of, say, record keeping, it works well for computing and for machines. So, for example, 0 can be off, 1 can be on. Or in Morse code, you have no sound, which is the off, and a tone or a sound, and that is on. Now, again, in Morse code, the variable between a dit and a da, right? I believe it's 3 dits to a da. So again, that's a value over time. So you can actually build a square on for 2 seconds, off for a second, or on for a second, off for a second, on for a second, off for a second, right? So that would let you build in dits and das, zeros and ones, or offs and ons. And that's an early form, or that's a way that we can understand binary. So even like, with communicating via light, right? They would do that in the military as well. So again, binary, zeros and ones. Very simple. 0 is 0, 1 is 1. What happens to 2 though? Because all you have is zeros and ones. Well, just like in normal base 10, you just add an extra digit to the left. So 0, 0, 1, 1, 2 becomes 1, 0. 3 becomes 1, 1. 4 becomes 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. And if I did my math correct, 7 is 1, 1, 1. But 100, right, 100 in our decimal world actually equates to be 1100,100 in binary. So it's not a very efficient way to store information into memory on a computer or in anything that operates with a computer, right? But for logic, binary is great. True versus false, yes versus no, on versus off. Now, when I was in school, in college, I used to love playing around with logic gates. That was one of the courses that I really excelled in. So, AND gates, NOR gates, ANDs, ORs, all of those, right? To me, that was a lot of fun. And again, that's still the basic of when things come to ICs and CPUs and everything else, right? It's all ons and offs, yeses and nos, trues and falses. So, already, by now, we've already done decimal and binary. So let's do octal, right? Octal is a 8-bit system. This is how we save just a little bit of room in a system. So 8 bits, 0 through 7, those make up the 8 bits. And a byte is a unit of memory that makes up 8 bits. So I don't know about you, but I still remember booting up an old 8088 or 8086 computer and watching it very carefully and very slowly count the memory that we had, right? What was it? 8 megabytes or 1024 kilobytes, right? It would start at 0 and count its way up. And you sit there and you'd watch it go, and you add more RAM and you'd watch it go even further, right? So remembering those old days, I can't imagine how long it would take to boot up a computer if a computer these days had to count from 0. I mean, the computer I just bought here has got 64 gigabytes of RAM. It's unbelievable how much memory is in this thing and how much memory we all started off with, right? It's a good time to be alive, right? So anyway, how do we look at the octal system? Well, it's easy, right? 0 through 7 is 0 through 7. It still starts at 0 and goes up to 7. But what happens when you hit 8, right? Well, that becomes a 1, 0. And then 9 becomes a 1, 1. 10 becomes a 1, 2 until you get to 1, 7. And then, of course, then you go 1, 0, 0. So, because again, it's 8 bits starting at 0. So 0 is actually your first bit here. So 100 in octal, again, if my math is correct, is 144. Notice I didn't say 144. It's 144. So at this point, 100 in decimal and octal are still 3 characters long. 100, 100 versus 144. But remember, binary is inefficient. Binary is actually 1100 100. But you must be saying, hey, Phil, there must be a more efficient way to store values into memory. And I assure you there are. And we'll talk about that on the other side of this break. Did you know there are ways to help support the Scanner School podcast that doesn't take any time or any extra money on your part? If you go to scannerschool.com/support, you will find we have several ways that you can continue to do your online shopping and help support us. We have links to Amazon. If you click on our link before you go to Amazon, anything you buy from there will help support Scanner School. Now, if you're in the market for a brand new scanner, an antenna, other accessories, we have links to Scanner Master, where you can not only purchase a scanner and accessories, but you can also get your radio programmed. And by clicking on our link before you buy, you are helping to support the podcast. Now, if you're in the market for software, we have links to Butel. And if you want something new to you, we also have links to eBay. Again, just go to scannerschool.com/support before you make your purchases, and you are helping to support Scanner School at no additional cost to you. This session of Scanner School is sponsored by East Coast Pagers. Now, East Coast Pagers is one of my online companies, and we are a Unication, Apollo, and Swiss phone dealers serving the North American market. Now, if you're looking for a personal use pager or one for your department, we can get you a quote at the very best prices. So why does a company like East Coast Pagers support Scanner School? I think that every scanner radio user should at least put one pager in their collection of radios. The reason why is very simple. It frees up your scanner to just do scanning, and then you have one radio that's dedicated to your local fire activity. Now, with a pager, you can have voice storage. You can do tone outs. You can keep it silent. You can go back the next day and listen to what you've missed overnight. It's more than you can do with an out-of-the-box scanner. And with today's pagers having multiple frequencies and even having multiple channels in a scan list, like the Unication G1 can do 8 channels in a scan list. It has 64 memory channels, and out of the box, it comes with 11 minutes of stored voice and a desktop charger. The G2s to G5s, they do P25 Phase 1 and Phase 2 in simulcast environments with stored voice, paging on conventional NP25. Oh, and they're upgradable too to DMR Type 1 and Type 2. They are more rugged than today's consumer-based scanners. And with a pager like a Swiss phone S-Quad, you won't even realize you're wearing one. It'll help keep you informed as to what's going on in your neighborhood. So again, eastcoastpagers.com or contact me directly, phil@eastcoastpagers.com. Do you have a new scanner? You're having problems understanding how it works? Maybe you're new to the entire Home Patrol database of programming and you can't figure out Sentinel. Did you get a new SDR and you're trying to figure out how to install it? Or you want to learn how to use Unitrunker, DSD+, maybe set up a PieAware, or even just make some changes and you don't understand how this system and the equipment works? The podcast might be great for you, but maybe you need a little bit more of one-on-one help with setting something up. I'm available to do just that with you with our private tutoring sessions. You can book me online by going to scannerschool.com/consulting for a 1-hour session. And it's great because we can actually share computer screens remotely, and I can guide you through step by step as if I was sitting right next to you. So again, book me for an hour at scannerschool.com/consulting for your Scanner Radio one-on-one tutoring session. National Communications Magazine is your personal library of scanner, CB, GMRS, FRS, MURS, and 2A radio articles written by the best minds in the business over the past 3 decades. Your NatCom personal online access account allows you to download the newest issues of America's Hobby Radio magazine, as well as back issues too. So visit natcommag.com to download your free sample issues and sign up today. That's natcommag.com for National Communications Magazine. All right, so let's talk about this more efficient way to store values into memory. And again, I assure you this all has to do with scanning, okay? Let's enter in the ring hexadecimal. This is a 16-base system with values of 0 through F, okay? So 0 through 9 is the same, 0 through 9. But 10 becomes A as in alpha, 11 is B as in Bravo, 12 is C as in Charlie, 13 is D as in Delta, 14 is E as in Echo, and 15 is F as in Foxtrot. Those are our values, 0 through F. So the number 100 is actually a 6-4. So we lose a bit in that equation. So let's talk about a magic number in hex. F, 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 F. In the radio world, this can be a wild card when you program up certain radios. Example, could be a wildcard trunking flag. It could be an open squelch. It could be anything, right? And again, we're going to talk about other things in a few minutes here, but when it comes to programming certain radios, that's the wildcard. So FFFF in hex is actually the decimal number 65535. In binary, though, it's 1111 1111 1111 1111. All right. So how does all of this relate to scanning in the radio world? Well, have you ever looked at the trunking sites in the radio reference database? Hopefully you have, and hopefully you understand what you're looking at. But let's take a look at my local county's trunk system. And I say, let's take a look. I mean, I'm going to take a look and I'm going to narrate what I see to you. So the first thing we notice when we look at it is we have a system ID, right? And my Nassau County Public Safety P25 trunk system has a system ID of 1AE. That's 1 Alpha Echo. That is a hexadecimal number. The WACN, the WACN. This is a Motorola world here, right? So it's BEE00. That's Bravo Echo Echo 00. Now, again, if this was a Harris system, Harris uses a unique WACN ID for all their systems, whereas Motorola seems to default to BEE00. The system IDs are all unique, by the way. So again, we have hex on here as well. As we scroll down the page, we have an RFSS and a site number. Again, the RFSS has a decimal number, and then in parenthesis, it has the hex value of that. Same with the site, 001, 002, 003. That's the decimal number. But in parenthesis, 1, 2, 3. Alpha, Bravo, Charlie, Delta, if it went that far. So again, you can see that we have these values in radio reference. Okay, well, what about on the talk group table? We have a special column here for hex. So you've got decimal, right? Channel number or talk group number 1102. Right next to it, you've got hex 44E, 44 Echo. Then you got 1103 is decimal for the next talk group, 44 Foxtrot, so on and so forth. So you can start looking at how things are built and defined and how they come up with these numbering. And as you start looking at the hexadecimal numbers, you can kind of see how they broke things up in the programming table. For example, countywide fire talk groups here just happens to start with 4001. But why does it start at 4001? Why pick that number? Well, that ends up being FA1, and then FA2, and FA3, and FA4, right? It's a brand new settings in hex. They could have gone FA0, and that would have been talk group 4000. Maybe there is a 4000. Maybe they didn't put one in there, right? But that's how they started things in here. And as you look through other systems and other talk groups, you'll start to notice that, hey, maybe they are breaking things up either in a decimal value or hexadecimal value. Again, with the sheriff's talk groups on this system, they just start at 5,000 in decimal. Not really so pretty in hexadecimal. But why are we looking at hexadecimal numbers when it comes to programming our scanner? Well, in the two-way world, in the Motorola world, you would program your radio, your two-way radio, using hex. So that's where a lot of things get read from. So if somebody is reading their two-way that was issued to them, they're going to get the values back in hex. So if they submit the data to radio reference, they're going to say, oh, this talk group is for X, Y, and Z. But you also have the option of programming your scanner in hex. Not everybody does it. I truthfully stick to decimal formats when I program my scanners. When I look at the talk groups in my scanners, unless it's EDAX, I prefer to look at it in decimal format. Side note here, my local EDAX system is now gone the way of the dodo, so we're kind of mourning the loss. No more EDAX, no more monitoring that funny EDAX end of talk group tone that used to go out. Those days are gone. I looked at radio reference the other day, and there's no EDAX anywhere near me now. So hang my hat up, pour a drink out for EDAX. All right, going back to what we were talking about here. But you can see that hexadecimal is alive and well in the radio world. Let's talk about P25. Well, P25, we see hexadecimal in the NAC codes, right? So the network access code, our filtering, right? 293F. It's 293F. It's something similar to that. Don't hold me to that one. But again, right, those values there are in hex. Even DMR, right? We use hex when we program up and look at stuff in DMR. So hex is a value that is very front and center when it comes to a lot of these systems, especially in the digital world in scanning. So I felt it was pretty important today just to go through some of the information that you'd see online, some information you'd see in radio reference, and talk about basically how we went from decimal, why we gravitate into hexadecimal because it's pretty efficient, and kind of help you out and show you what some of the numbers are and where they came from in case you didn't know. Because again, not everybody has the same background. And again, that's the point of the podcast here, right? Is to kind of teach everything to know. And this is something that, while I take it personally as second nature because I have a background in this, not everybody who gets in the hobby has a background in this kind of information. So, you know, like some people, they grow up in a 2-language household and they take speaking 2 languages or 3 languages as second nature. I don't. I can only speak 1 language semi-well. If I learned a second language, it wouldn't make me any more gooder. Anyway, so that's where things are with this, okay? And again, it's, if you look at the world again with software-defined radios, a lot of the stuff and a lot of the stuff you look at in there too can be displayed in a computer language, which ends up being in hex. So with that, hopefully you now understand why we look at hex and we see hex when we look at radio reference, why the system IDs are the way they are, why the WACN IDs are the way they are, is because they are very efficient to use a 16 base system rather than a 10 base system. Now, again, if you want to learn more about this and see more about SDRs, you can always check out our free and our advanced SDR training course over at courses.scannerschool.com. Don't forget, You can download all the links we talked about today, which I think was just the training course, over at scannerschool.com/session175. Also, make sure you're subscribed to our podcast by clicking on the subscribe button on your podcast player. Or if you're listening to us on YouTube, please make sure you click the subscribe button and click on the bell so you are notified when our next podcast comes out. Also, too, on our website, we have a form on the front page where you can sign up for our weekly email newsletter. And again, remember, if you've enjoyed this podcast and there's something in here you'd like to share with somebody else, please send it to them. Our goal is to help as many people as possible with the scanner radio hobby, and we can only do that with your help. So please share the podcast with everybody you know who is in the scanner radio hobby. So again, my name is Phil Lichtenberger, and this is Scanner School. We teach you everything to know about the scanner radio hobby. We'll catch you all again next week. 73.